Hello everybody. Today I thought that I'd give a short tutorial on resonance structures. So I will draw us out a condensed formula for a molecule here. And I'm not going to draw the whole thing because that would take a while. And I don't think that anyone would really enjoy sitting through that because that's not what this video is about. If you want to look at the drawing stuff, watch my previous video on bond line drawings. But so this here is going to be the structure that we're working with. But it's still not quite finished. We've got to add in our lone pairs that are here on sulfur. And even now, in concerning resonance, our structure is still not complete. There's something with this carbon that we need to add, and that has to do with its formal charge. And there is an equation for that to figure out whether an atom has a charge associated with it. So the formal charge equation, I don't need to add the carbon just yet. The formal charge equation is the valence electrons minus the non-bonding electrons plus the number of bonds. So for our carbon here, I'll show you where that carbon is. See, there's a junction here. So there's a carbon right there, there, there. Well, there's also carbons here. That's it. That's not what. It's this carbon here that we're focusing on right now for this valence equation. So carbon has 4 valence electrons, and it doesn't have any non-bonding electrons on it right now. So that's a 0. And it's got 1, 2, 3 bonds. 4 minus 3, 1. Now, this equation, since it gives us this 1, that's telling us that there is a positive charge here on this carbon. Now, why is that the case? Carbon's valency is 4, which means it likes to bond 4 times. And since it's only got 3, that's why it's got a positive charge with it, because it's not in its normal type of bonding situation. Now, when it comes to resonance, that has to do with the moving of electrons, where it's still technically the same molecule. It can occur in either state. And it has to do with these electrons here, and particularly in double and triple bonds as well. And they're called delocalized electrons, which means they can move around. So the electrons in this bond can go from there to there, and these lone pairs can go here. And then we have structure that looks a little something. Artist drawing. Looks a little something like this. See now how that there's a double bond there now, and these electrons that were in the double bond there have been moved over here. So now there's a double bond there. Still a single bond there. And there we go. But there's also still 1 lone pair left on this sulfur. But now there's only 1 lone pair left on this sulfur, because as is depicted with the curved arrow that is used in resonance, these electrons have been moved down from this atom and on to this bond here, creating a double bond between the sulfur and the carbon. And there is the carbon here, here, and here. So this carbon, 1, 2, 3, 4. It's got 4 bonds. Its octet is full and it's heavy. And this carbon, 1, 2, 3. Uh-oh. It's only 3. No, not 4 like it likes. So if we were to do the formal charge for this carbon now, 4 valence electrons, no lone pairs, plus 3 bonds, same as before, it's the 1. So now this carbon has the positive charge. And this one has 4 bonds in it. So the charges also get moved in resonance structures. And this is only one resonance structure for this. It can have many different examples. These lone pairs can be moved and these bonds can be moved, and a lot of the times molecules that have resonance will have several different resonance structures that they could be in at any one given time. So be sure to experiment, move the electrons around a bit, and make sure you find all of them, because those are common questions on exams. So I hope this was helpful. I hope this revealed a little bit more about resonance, helped you understand it a bit. If you've got any questions, leave them down in the comments or send me a tell, and I will see you guys next time. Thanks for watching.